All right, so now let's take a look at some example problems that we can put to where we can put those perpendicular bisector and angle bisector theorems to use. Example 1 says find the length of segment WY, right? That's what it means when we just see capital W, capital Y. Find the distance from point W to point Y, or find the length of that segment WY. Well, in this picture, I see that from X to W is represented as 5n minus 2. From W to Y is represented as 2n plus 7. I see that I have a segment ZW that is perpendicular to segment XY, and point Z to point X is the same distance as point Z to point Y, right? Segment ZX is congruent to segment ZY. Well, there's kind of a couple ways I could look at this. I could actually think back to what I learned in the previous chapter, and I could notice that these two triangles have to be congruent by HL. They're both right triangles. Their hypotenuses are congruent, and then this leg here would be congruent. So if they're congruent by HL, then their other remaining parts would have to be congruent. So XW would have to be congruent to YW. I could use that idea. Or I could use the converse of the perpendicular bisector theorem. Because point Z is equidistant from the end points of segment XY, and it's also on this segment that's perpendicular to segment XY. So this segment ZW must be perpendicular to, it is perpendicular to segment WY, and Z to X is the same distance as Z to Y. Therefore, segment ZW is the perpendicular bisector of segment XY. And if it's the perpendicular bisector of segment XY, that would imply that from X to W is the same distance as W to Y. All right? Of course, we could also have just looked at the fact that these triangles are congruent, and that means these parts are congruent. But in any case, we now know that we can take the 5n minus 2 and say it equals the 2n plus 7. Then we can put our algebra skills to use here. We can subtract 2n from both sides to get 3n minus 2 equals 7. I'm going to add 2 to both sides. That's going to give me 3n equals 9. I'll divide both sides by 3. That takes me to n equals 3. Of course, we're not done because it actually asks us to find how long it is from W to Y. WY, it says, is 2 times n plus 7. So now we know that's 2 times 3 plus 7, which is 6 plus 7, or 13. So there's our answer for the distance from W to Y. Example 2 says find the distance from O to L. Now this is a pretty complex picture here. I might want to notice that I have maybe a couple triangles that I'm going to kind of focus in on one at a time. Triangle JKL, I see has point K equidistant from the endpoints, right? This distance is the same as this distance. And point K is on segment KN that's perpendicular to segment JL, the other side of this triangle. That tells me that from J to N should be the same distance as from N to L. So J to N equals 14. That's the same as N to L. So now I know, okay, N to L is 14 units long. I'll kind of add this to my picture. I'll say that is 14 units long. I then can kind of zoom in on triangle LMN and notice that I have the same situation happening with M. It is equidistant from L and N. It is on a segment that's perpendicular to the third side of this triangle, NL. So it must be on the perpendicular bisector of segment NL. So O is splitting segment NL into two equal parts. So if N to O and O to L are the same, right? N to O is the same as O to L, but N to L equals 14. I guess I already had that written up there. I don't need to write that again. Then these two imply that n to O is going to be just half of 14, which is 7, which will be the same thing as O to L. So there's my answer. Each of these parts would be 7. O to L is 7. Now in the last example we're going to be looking at, we have this diagram, and it's kind of a two-part example. It says, first of all, part A, if HI is 7, IJ is 7, and angle HGI is 25 degrees, what is angle IGH going to be? Well, why are they telling me that these two things are 7? I notice that those two segments, IH and IJ, are both perpendicular to the sides of angle HGJ. IH is perpendicular to ray GH, IJ is perpendicular to ray GJ, and they are the same length. So point I is equidistant from the sides of angle HGJ, right? I is equidistant from the sides of angle HGJ. So that means that ray GI bisects that angle, angle HGJ. If ray GI is bisecting this angle, it means that, therefore, angle HGI should be congruent to angle JGI. I know this is true in this picture. So if angle HGI is 25 degrees, the measure of angle JGI is the same as the measure of angle HGI, which is 25 degrees. So there's my answer for part A. Now part B gives us some new information about my picture. So let me get rid of these measurements. Part B says angle HGJ is now 57 degrees. All right, that is 57 degrees. Angle IGJ is 28.5 degrees. So this angle is 28.5 degrees. HI is 12.2. What is IJ? Well, why does this matter that this whole thing is 57 and this part's 28.5? If I take 57 degrees and I subtract 28.5, I'm left with 28.5 degrees. That means that is the measure of angle HGI right here. This angle would also be 28.5 degrees. So that now means that ray GI, so therefore ray GI bisects angle HGJ. It's cutting angle HGJ into two equal parts. So that means I can now apply that angle bisector theorem, and any point that's on that ray, any point that's on ray GI, should be equidistant from the two sides of angle HGJ. Well, point I is on that ray, and IH is the distance from I over to this side. IJ is the distance from I over to this side. Those should now be congruent. So IH should be the same length as IJ. If IH equals 12.2, then that is going to be the same distance for IJ, and there's my answer.